Okay, students, I'm here to go through Study Guide Unit 6 on Statistics. I'm going to go through every question. We have gone through this unit pretty quickly, so hopefully I will answer any questions you may have. Feel free to pause as you go along so you can answer the question, then look for the answer, see if you got it correct. That would be the correct way to do it, not just to sit here and listen to Ms. Hare give all the answers, but to actually pause it as you go. If you don't understand, rewind and start again. So let's start with what we first learned. We learned about statistical questions. Remember, statistical questions have to have lots of answers. You have to generate lots of answers. Which of the following is a statistical question? How tall is the governor of our state? Well, if we ask that, we only have one governor. It's going to give us one answer. How many foreign countries have you visited? If you ask me how many countries I've visited, I'm going to tell you one number. Not a good answer. What is the temperature right now? I'm going to give you one number. The temperature is 60 degrees. What were the heights of the students in my math class? I'm asking all the students in my math class. That is a good answer. So statistical question has to have lots of answers. Our newest thing that we've learned about is how data can be skewed. So you have some histograms here, and we're going to talk about how they're skewed. Data can have a variety of shapes. In a data set that is skewed, most of the data lies on one side or the other, rather than in the middle with the mean. Identify which type of data distribution is known. So if you look at this, you see how it's more on the right side than it is on the left side. So because the data is pushed to the right, we actually call that skewed left. Okay, there's a tail, they call this like a tail down here. You can see it goes up and then comes down. So it's skewed to the data is higher on the right, but that actually means skewed left. Here you have that bell-shaped curve, evenly distributed. So that is a normal curve or a symmetrical spread of the data. Over here, you can see that the tail will be here, and you go up over on the left side. So since the tail is on the right, we call that skewed right. I always think if the data is pushed to the left, it's the opposite, it's right. If the data is pushed to the right, it's called the opposite, skewed left. Which of the following are considered measures of variability? Which ones do we use to talk about the spread of the data? Mean, median, and mode are used to measure the center of the data. So range and interquartile range is how we measure the spread of the data. Number 4, which of the following are considered measures of center? Mean, median, mode, measures of center. They talk about the middle of the data. Valdemir recorded the number of siblings, brothers and sisters, each of his classmates has in the dot plot below. So he went and asked people, how many siblings do you have? You can see here that 1, 2, 3, 4, 5 people said they had no siblings. And of course, this would be number 1, number 2, number 3, number 4, siblings. Okay? This guy right here, this student right here, is considered an outlier. We talked about that with the skewed data. This guy is going to mess up the average completely. Okay? This is a skewed right graph. This outlier is going to mess up the data. When we did our examples, if we have an outlier, what do we use? Since not everything is centered around the middle, it's not centered around the mean, we have to use the median. Okay? If you have an outlier, you must use the median. If there's no outlier, use the mean. We don't usually talk about interquartile range when we talk about the measure of center. Remember, this would be the measure of spread. Okay, number 6. Trey recorded the number of ounces of water he drank each day in the histogram below. Trey's daily water drinking, so the amount of water. So number of days. So he drank 1 to 10 ounces 2 times. He drank 41 to 50 ounces 7 times. He drank 51 to 60 ounces 4 times. He drank 61 to 70 ounces 5 times, and he drank 91 to 100 ounces 3 times when he recorded his data. Right here, we consider this a gap in the data, remember? And I would say there's also a gap in the data here. Okay? How many days did he drink between 51 to 70 ounces? So from 51 to 70 would include this bar and this bar. Well, this bar says 4 and this bar says 5. So what is 4 plus 5? 9 times. So he drank how many days? 9 days, I should say. He drank between 51 and 70 for 9 days. How many days did he drink 41 ounces? 41 would be in this bar right here. But this interval, because it's an interval, we don't even know if he ever drank 41 ounces. He could have drank 52, 54, or I'm sorry, 42, 44, 49, 50. We don't even know if he drank 41 ounces. So that's the one that we say can't be determined. Cannot be determined because you don't know which of those in that interval he was actually drinking. Chantel recorded her bowling scores for the quarter in the table below. So here's all her bowling scores. If she makes a histogram with intervals of 90 to 99, 100 to 109, 110 to 119, 120 to 129, what is the height of the bar for the interval 120 to 129? Excuse me. So let's pretend that we make like a frequency table and we have all these intervals. We need to know how many of these scores would fall in this interval. So 120 would fall in that interval. 124 would fall in that interval, 125, 123, and 127. So we have 1, 2, 3, 4, 5 data pieces that would fall in that interval. Okay, I could ask you how many data pieces fall in the interval 90 to 99. So that would be 1 there, 2 there, 3 there. So your answer could be 3. So depending on what interval they're using, you're just counting the data. Brandon recorded the weights in pounds of the fish caught while fishing with his uncle. His data is shown below. So the weights in pounds of the fish he caught. So he caught a fish that was 4 pounds. He caught a fish that was 11 pounds. He caught a fish that was 15 pounds, and so on. Make a line plot to display the data. Using the line plot, determine the mean, median, mode, and range. Round your mean to the nearest tenths place. Okay, so to do a line plot, I got to have a number line. So my lowest piece of data is 4. My highest piece of data is 15. So I'm going to start at 4, and I think I'm just going to count by ones, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so making a line plot, remember. Okay, so I need to have a 4 right here, and then I'm going to go to 11, and then I'm going to go to 15, 8. Remember your x's, keep them equal size. I'm going to go to 10, 2 6s, another 4, a 5, a 7, and a 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make sure you have 11 pieces of data and 11 x's. So now I need the mean, median, mode, and range. Well, I'm going to start with the range because that's easy. The range is the highest minus the lowest. My highest piece of data is 15. My lowest piece of data is 4. 15 minus 4 is 11. That's the range. Mode, which one occurs the most often? So we actually have a tie here. 4 and 6 both occurred twice, so we have 2 modes, 4 and 6. The median is trying to find the middle. So you can do our strategy where we cross off one from either side until you get to the middle. So who's in the middle? You should have 7 in the middle. If you want to, and you want to lay out your data, 4, 4, 5, 6, 6, 7, 8, 9, 10, 11, 15, I can count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You can see that 7 is in the middle. So if you'd rather count it out or lay it out in line and then find the middle, that's fine too. So our median is 7, and now we need the mean. The mean is when we add up all the numbers. This is where you got to be careful. You got to add up your original data. So when you add up 4 plus 11 plus 15 plus 8 plus 10 plus 6 plus 6 plus 4 plus 5 plus 7 plus 9, when we add up all the data, you should get 85. And then there's 11 pieces of data, so I'm going to divide by 11. 85 divided by 11 gives me 7.72, but it says rounded to the nearest tenths place. So that means the 2 tells the 7 to stay, so my final answer should be 7.7. Again, I'm adding up all these numbers and dividing by 11 the number of data. Okay, Jordan's test scores are 85, 90, 89, 75, 90, 92, 81. What is the average or the mean? Average is another word for mean. So we're going to add up all the numbers, add up all your numbers, divide by 1, 2, 3, 4, 5, 6, 7. When you add them all up, you should get 602. Divide it by 7, your average is 86 test average. Remember, for the test, you will not be able to use your notebook. So if you've used your notebook on the quiz and such for mean, median, mode, and range, you better make sure you're studying how to calculate those because you will not be able to use your notebook. Adam recorded the number of flower blooms on each of his 10 rose bushes. Determine which of the box plots below matches Adam's rose bush data. So we have the data and we want to match the box plot. So what kinds of things do we look for in the box plot? We look for the lower extreme, which is otherwise known as the minimum. We look for the upper extreme, which is otherwise known as the maximum. We look for a median. We look for the lower quartile, and we also look for the upper quartile. So I'm going to start with minimum, maximum first, because those are the easiest. If I look at this data, my minimum is 4. And if I look at the data, my max looks to be 18. So first thing I'm going to do is I'm going to go through the data and look and make sure the min and max are 4 and 18. Minimum is 4, max is 18. Minimum is 4, max is 18. Minimum is 4, max is 18. Max 18, minimum 4. So I wasn't able to eliminate any of the answers. Next I'm going to do is find the middle. So in order to find the middle, I have to put the numbers in order. So I'm going to put the numbers in order: 4, 9, 10, 10, 12, 12, 13, 15, 17, 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, I have an even number of data, so I'm going to have 2 middle numbers. 1, 2, 3, 4. 1, 2, 3, 4. So I have 2 middle numbers. Since the 2 middle numbers are the same, I know that the median is going to be 12. But if they weren't the same, you would add them up and divide. And I can still prove that. 12 plus 12 is 24. Divide by 2, and you get 12. But if they're the same, you know it's going to be 12. So the next thing I'm going to do is look at each line, because I know that the line in the box plot is the median. So this median is at 12, so that works. But this median is at 10, so I can go ahead and eliminate C. This median is between 8 and 10, which is probably about 9, so I'm going to eliminate D as well. And this median is at 10, and I need a median of 12, so B can be eliminated. So now I have A as my final answer. Now, if they all had the same median of 12, I would have to find the lower quartile and the upper quartile. And I'm going to show you how to do that just in case you forgot how to do it, and maybe I would have to get the lower quartile and the upper quartile in order to figure it out. Now, lower quartile is the middle of the lower half of the data. When you have 2 middle numbers, you have to use that 12, okay? If you have upper quartile is the middle of the upper part of the data. You have to use that 12. Now, if there was only one middle number, you would ignore it, and you would just find the middle and find the middle. But because we have 2 middle numbers, we have to include it. So this is my lower quartile. So I'm going to count until I get to the middle. I have 2 here and 2 here, so my middle number over here would be 10. So my lower quartile is 10. My upper quartile, I have 2 here and 2 here, so my upper quartile is 15. I'm going to double check and make sure lower quartile is at 10, upper quartile is at 15. So it does double check and work out. Please study this. You're going to have to know this for the test. As you can see, I didn't actually have to draw the box and whisker plot, but I still had to go through all the steps to find each part of the box and whisker plot. Y'all kind of struggled with this on the quiz. So stop, pause the video, and try it again. Make sure you know what you're doing there. Have some, after we make the box and whisker plot, we then talk about percentages. Okay, so 11 through 16 here is talking about the percentages of the graph. Okay, and just being able to read the box and whisker plot. The number of items bought at the grocery store. So this box and whisker plot is representing what I buy at the grocery store. What do I need to know about this box and whisker plot? Well, we did these parts, but you also need to know about the percentages. A box and whisker plot has 4 sections. One section here, this is 25% of the data. This section is 25% of the data. This section is 25% of the data, and this section is 25% of the data. That's why they're called quartiles. Okay? What is the maximum value? So that's easy. I'm just going to look at the highest point and I'm going to say 65. What is the median of the data? You need to know that the line in the middle of the box is your median. So the median of the data is 55. Again, you will not have your notes to look that up. Make sure you study. This is the median, that middle line of the box. What percent of the data is below 40? So if you look at 40, what percent is below 40? How many sections are below 40? There's only one section, so that would be 25% of the data is below 40. What percent of the data is below 60? So 60 is the upper quartile. Below 60 is one section, two sections, three sections. So that means 75% of the data is below 60. What is the IQR? Remember, the interquartile range tells us about the middle of the data. IQR is the box. What's happening in the box? So IQR is the upper quartile minus the lower quartile. Range is the max minus the min. We want the max minus the min of the middle of the data. Remember, IQR is the middle of the data. Okay, IQR. So I want to know the max and min here. Well, the upper quartile is 60 and the lower quartile is 40. So I'm going to find the difference between 60 and 40, which is 20. My IQR is 20. The numbers in the middle of my data spread 20 numbers. They vary by 20 numbers. What is the range? The range is your upper extreme minus your lower extreme, or your maximum minus your minimum of all the data. So the upper extreme, upper extreme is 65. The lower extreme is this dot over here, which is 25. 65 minus 25 is 40. So my range is 40. All the data range is 40, but the middle of the data range is 20. Double check you know how to do all of those things. Stop, pause, rewind, do what you need to do to make sure you understand how to calculate all of those items. 17. The owner of an independent music store monitored CD sales over a period of days. The histogram shows the results. Explain the empty 80 to 90 interval. So right here, there is an emptiness. So the number of CDs sold, this is the number of days. So from 0 to 10, there were only 2 days that we sold 0 to 10. There were only 3 days we sold 10 to 20. There's only 1 day we sold 20 to 30. Now, I will have to argue that this graph is not a great graph because the intervals are overlapping. But for sense of talking about the emptiness, what does that mean? That just means we never sold between 80 and 90 CDs. So if there's a gap, that never happened. So we never sold 80 to 90 CDs. Question. Okay, I guess I can't ask you a question. That was a dumb question, Miss Hare. Sorry, guys. All right, find the mean, median, mode, and range. So now we have a line plot, and I want you to find the mean, median, mode, and range. Well, my first thing I like to do is I do not like to do the median with this. I like to have my data. I like to see it. So I'm actually going to write my data out. I have 1 0. I have 2 4s. I have 3 8s. I have 2 12s. And I have 1 16. You don't have to do that. But to do the mean, you pretty much have to do that. And I like to use it to find the middle because the crossing off doesn't always work for me. But you guys decide how you want to do it. I'm going to start with mode because that one's pretty easy. Do we have any numbers that repeated? I'm sorry, which one's repeated and which one repeated the most? So 8 was the most popular, so 8 is our mode. 4 repeated twice, and so did 12, but 8 repeated 3 times, so that's our mode. My range is the highest minus the lowest, so 16 minus 0, 16. Median. Median is find the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have an odd number of data, so I should be able to have the one middle number. My median is 8. 4 on this side, 4 on this side. You can cross them off, cover them up as you go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2, 3, 4. And you have your 8 in the middle. Okay? You can also do it this way. Cross off here, cross off there. Cross off here, cross off there. Cross off here, cross off there. Look where I end up. I end up in the 8s. So that's your median. Now, my mean, I got to add up all my data. This is where the part that you guys get confused. Some of you like to add up 0 plus 4 plus 8 plus 12 plus 16. But you have to add up how many times it occurs. 0 plus 4 plus 4 plus 8 plus 8 plus 8 plus 12 plus 12 plus 16. When you add that all up, you should get the number 72. We have 9 pieces of data, so I'm going to divide by 9. So my answer is 8. My mean and my median are actually the same, and so is my mode. All right, 19. The heights of in inches of 7 baseball players are listed below. These are the heights of the baseball players. What is the interquartile range of the heights? Well, in order to do the interquartile range, I would have to find the middle, put them in order, and all the things. So I'm going to do that. I'm going to put these numbers in order. They are out of order, so I need to put them in order. 73, 74, 76, 79, 83, 84, 88. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to have one middle number, 1, 2, 3, 1, 2, 3. What's my middle? My middle is 79. How do I calculate IQR? Remember, IQR is the difference between the lower quartile and the upper quartile. So I need to get the lower quartile and I need to get the upper quartile. My lower quartile is going to be the middle of the lower half of the data. My upper quartile is going to be the middle of the upper half of the data. So this is the upper quartile and this is the lower quartile. If you notice, this one's different than the one we did earlier because there's only one middle number. If there's one middle number, you leave them out. What we did earlier is we included the middle number because there was 2 middle numbers. So over here, we included the 12 over here and the 12 over here. Make sure you know how to do that. So the middle of the lower half of data, is 74, and the middle of the upper half of the data is 84. So if the lower quartile is 74 and the upper quartile is 84, IQR is the upper quartile minus the lower quartile. So 84 minus 74 is 10. So your answer would be A. You mean I have to do all that work just for one answer? Yes. You have to put the numbers in order, find the middle, find the middle, find the middle, then subtract. It's a lot of steps, but you can do it. All right, 20. Now we're going to put this all together again with the box and whisker plot, so another chance to get some more practice. Alan recorded the number of baseball cards that were traded at a local hobby store. Use the information to find the following statistical measures. So I'm going to put them in order to help me get started. So 100, 100, 110, 135, 45, 150, 155, 155, 160, and 170. Now this question doesn't say build a box plot, so don't worry about doing that. But you do need, in order to find all these things, you've got to have them in order. So the first thing I'm going to do is find the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 2, 4, 6, 8, 10. So it's going to have 2 middle numbers. I'm going to have 4 over here and 1, 2, 3, 4 over here. I have 2 middle numbers. When I have 2 middle numbers, I add them up and I divide by 2. So 145 plus 150 is 295. I'm going to divide it by 2, and you should get 147.5. So that's my median, 147.5. Okay? Now, I can do minimum. Minimum's easy. That's 100. Maximum, 170. Now I need lower quartile, upper quartile, and interquartile range. Well, in order to do interquartile range, I need these two. So I'm going to find the middle of the lower half of the data. Since there's 2 numbers, I have to include the 145. Okay? And over here, I'm going to include the 150. So, lower quartile, what's the middle of what's yellow? 2, 2, 1, 2, 1, 2. So what's the middle? 110. 1, 2, 1, 2. What's the middle? 155. Inner quartile range, that's the upper quartile minus the lower quartile. 155 minus 110. 155 minus 110 is 45. So my interquartile range is 45. You do not need to make the box and whisker plot, so don't worry about that. Again, still struggling with the lower quartile and upper quartile. Pause, rewind, watch it again. Last question, 21. Examine the box and whisker plot below, which shows the length of fish that were caught one afternoon by a group of campers. Which statement about the data in the graph is true? The range is 7. Well, I'm looking for something that's true. The range is 20 minus 5. The range is the max minus the min, so that gives me 15. So that is actually false. The upper quartile is 20. Well, the upper quartile is the end of the box. So not only do you need to know how to calculate the upper quartile, but you need to know that the end of the box is your upper quartile. Upper quartile here is 14, not 20. So that is also false. Excuse me. Interquartile range is the upper quartile minus the lower quartile. The upper quartile is 14. The lower quartile is, 8.5. So 14 minus 8.5, okay? And that's not going to get you 4. 8, 9, 10, 11, 12, 13, 14, so 5.5 is your interquartile range. It's not 4. The median length is 12. So the median, you can look right here and notice that, oh yeah, it is 12. So that is the one that is true. This is false as well. So D would be your answer. Hopefully that helped you. If you have any other questions, make sure you ask. Send Ms. Hare an email, send Ms. Moreland an email, send Ms. Straka an email, whatever you need to do to be ready for the test. Hope you all have a great day.